Okay, so I was asked to talk about the effects of smoke exposure on grapes and wine, and specifically on mitigation in the vineyard. So the first thing I want to show, I'm a little bit, is what happens during a wildfire. So during a wildfire, you have a lot of vegetation burning, and 20 to 25%, if you see there, 15 to 25% of vegetation consists of lignin. Now, on the left, you can see these structures. Now, that's the structure of lignin. And when lignin burns, it thermally degrades and releases a massive amount of volatile phenols. Now, the example you're seeing here is an example of glycol. So it's one of a range of volatile phenols that can be released in the air. Now, when they're released in the air, they can disperse on air currents, and they can also absorb onto debris like ash in the air and disperse that way. So what happens when you have fresh smoke reaching a nearby vineyard? Now, if you have grape bunches on that vineyard, and on the vines, there's an excessive amount of volatile phenols in the air. If there's a high enough concentration, you can get passive absorption into the grape berry itself. So it's actually inside, it's not on the outside. And part of the defense mechanism of this grape berry is to attach sugars. It has glycosyl transferase enzymes, and it can attach sugars to these range of volatile phenols it's being exposed to. So it can add 1, 2, or 3 sugars. So it makes the whole situation a little bit more complex. Now we know, and the Australians have done a lot of this work for us, that there's at least 7 free volatile phenols that have been correlated with smoke impact in grapes that could potentially result in a smoke-tainted wine. Now, all 7 of these free volatile phenols can now also have various glycosylated forms. So now it gets a little bit more complex, and most research labs actually analyze more than that, just these 7. Depending on the vegetation burning, you can have different volatile phenols being released and different combinations of these volatile phenols. But so far, research indicates that they will all still result in a smoke-impacted grape, and if enough of that is happening, a smoke-tainted wine. Another complex factor is the fact that we have both free and bound volatile phenols. So bound are those that have sugars attached to them naturally present in grapes. So if you send your grapes away for analysis and you get a number back, that doesn't mean that you have smoke impact because you have them naturally there. And depending on the grape variety, you can have different amounts naturally there. We're not 100% sure how region impacts these baseline amounts either. So we just started in our second year of trying to develop baseline for California in the 7 main varieties so that people can look at that data, at least in the background of what is normal for their specific variety and hopefully for their region as well. So this is unfortunately the situation you can have. There's not a consistent ratio of free versus bound volatile phenols. But we know it's possible that an excessive amount of what's in the berry can actually be in the bound form. There may be a varietal impact on this. There may be an impact of the timing when during the growth stage that these berries get exposed to the smoke. We're not 100% sure. I wanted to touch upon testing because I'm going to show you some results, and I want you to know what these results mean. So for the free volatile phenols, they're volatile, they're aromatic, and we can measure them with a gas chromatography mass spectrometer. And most labs now will give you more than just guaiacol and 4-methyl glycol. They will give you the full range of compounds. Now, then many labs also offer a total amount. Now, what's the total volatile phenols? That's when they release what is bound through acid hydrolysis. Now, you can use enzymes as well, but enzyme slurries doesn't seem to work that well, and they don't release a lot of the di or the tri sugars. So most of us actually use a type of acid hydrolysis. Standardly, we use 100 degrees for 1 hour, and you adjust that sample to a pH of 1 using a very strong acid like hydrochloric acid or sulfuric acid. So then it releases a lot of the bound to the free, and you can measure it in the same way that you would measure the free. So you get a total. So if you measure both the total and the free, you can subtract the free from the total and you can get an idea of the bound. So this obviously measurement doesn't give you exact amount of specific compounds. It gives you an idea of the amount that could be bound and that's there. It's more a qualitative indication of the amount of bound. Then there are also labs that actually will measure the individual bound compounds for you, but then there are actually non-volatile, so you need a liquid chromatography mass spectrometry techniques to do that. But we only have reference standards, commercial reference standards for 6 of these bound compounds. So for this technique, you get very accurate quantitative data of 6 compounds, but only 6, and there's many, many more. I do all this analysis, and I can tell you whether you do individual bound or total, they seem to correlate. They don't give you the same number, but they correlate. So I always suggest to people, do the most extensive analysis that you can, but please do bound as well, not just free, because free can give you an idea that you're okay when you're not okay. Because in some years, we see almost nothing in the free form and everything in the bound form. Many people ask me how to compare data between different labs. It's very difficult to do this. One of the things is they all do acid hydrolysis. The sample prep might be slightly different. And because most of these compounds, highest concentrations are present in the skins, if your sample had a little bit more skin contact or their lab procedure has a little bit more skin homogenization, it can change that number a little bit. The other thing to keep in mind is ISO-accredited labs have a acceptable variance in the number they give you, and it's usually 5%. So what does 5% mean? 5% means that if you send your sample into a lab and you get 3 numbers for the same sample, and the one gives you 2 microgram per liter, one is 2.1 microgram per liter, and one is 1.9 microgram per liter, that's actually the same number, because that's within the noise of 5% standard deviation. Okay, so when you look at data or you send multiple samples away, keep that in mind, that that's actually the same number and it's not significantly different. My suggestion to people are, find a lab you trust and try and stick to that lab, because you can compare numbers from the same lab with each other and start building an idea of what's baseline for your vineyards, what is the number for your grapes or wines when they actually do get smoke impacted. So probably the question I get the most often is, what's my risk? There's some smoke in my vineyard. What do I do? What's my risk? And it's a very, very difficult question to answer. What we do know is the fresher the smoke, the higher your risk. Now, this currently is based on total anecdotal data, and I want you to know this. This is based on huge fires that happened in Australia. A column of smoke moved over the ocean, came back after 24 hours, covered the whole of McLaren Vale, and they thought the whole McLaren Vale was going to be impacted, and it was not. And that's where this 24 hours come from. Now, people like to look at AQI, the air quality index. Something to remember is the air quality index is based on health measurements. So it usually has a formulation. It includes ozone and it includes particulate matter like 2.5 micron and 10 micron, because that's bad for your lungs. Now, what we're concerned about for smoke impact are volatile phenols. Okay, they're not particulate matter. So they don't get captured by the air quality index. So air quality index is not a measure of smoke taint risk. Yes, when the smoke is really fresh, the density of smoke could potentially give you some idea of how much volatile phenols are in there. But the older the smoke gets, the less that AQI actually means for you. We know volatile phenols actually breaks down pretty quickly in the air within hours through auto-oxidation. What we don't know is how their absorption onto particulate matter may change this degradation process, right, or auto-oxidation. And these are things we're currently trying to study so that we can do better risk assessment. So most of you may have heard that we have this multi-state grant, a specialty crop research initiative grant. This is UC Davis with Oregon State University, with Washington State University. And what we're trying to do is to develop a sensor network. And there's photos of 2 types of sensors that we're using. Now, these sensors We aim for 21 sites this year in California. Unfortunately, due to supply chain issues, we could only place sensor in 13 sites. Hopefully, all 21 sites will be up and running next year, next season. But what we're doing is we're measuring many things. You can see there carbon dioxide, carbon monoxide, nitrogen oxide, volatile organic compounds, and particulate matter as well, as down as low as 1 micron. I think the finer we go, the better it may correlate to the volatile organic compounds in the air. And the VOCs do capture some of the volatile phenols, although not all. We're also taking air samples at these sites to try and correlate air samples to what is being measured by these sensors, taking grape samples and doing microfermentations. So this year was a good year for baseline, getting an idea of what's the normal composition of air and of grapes and of the wines for these sites, so that when there will be or are going to be a smoke event, we can figure this out. And this data are all going to atmospheric scientists. They're going to model this to try and do a better risk prediction. What's the safe distance? Based on air currents and topography, we know topography has a huge impact. You know, are you on a hill? Are you in a low valley? What's that impact on your risk, and doing better predictions? Even at the very least, we can develop a low-cost sensor that you can put in your vineyard, and it can tell you yes, no for risk. So when you're yes for risk, yes, you need to send a sample to a lab and get detailed numbers. If it's no for risk, no, you don't need to send a sample away. If we're ever in a bad situation like 2020, hopefully we will not inundate our labs and can get numbers in a reasonable time. I want to share this. So this is a study that was done on Merlot grapes over 3 seasons, and they intentionally exposed vines to smoke at different key growth stages. Now, the main thing here is that basically what they found is from variation onwards, the grapes were more sensitive to smoke exposure. And it makes sense. Your berries being bigger, it's enlarged, so you have a bigger surface area that the volatile phenols can absorb into, and your skin is getting thinner and more permeable potentially. Now, here's the thing. That doesn't mean before variation that it's not susceptible. It is. We have plenty of examples in Australia that get smoke wildfires often much earlier in the grape growing season, that if you have enough volatile phenols in the air, even if you have a rock hard berry, it can actually have smoke impact and make smoke impacted wines. The good thing here is, and something else I want to say, from variation to ripeness, yes, there's a slow decrease in enzyme activity and perhaps in glycosylation, but there is no such thing that over-ripen is not sensitive. If you have a berry on the vine, there's some sensitivity there. The other thing is, I hear sometimes now that smoke is going to be in the soils and it's going to carry over to the next season. There's no data to support those kind of claims. There's no carryover. These volatile phenols absorb onto the leaves and onto the grapes. They do not overwinter. I've now worked with sites. Some of them had smoke exposure 3 times and went back in the year where there was no smoke exposure. We made wines. There's been no impact. So currently, we do not see that as an issue, no carryover to the next season. So what about mitigation in the vineyard? What's out there? So I want to quickly talk about studies that others have done before I get to my own work. So the strainers looked at kaolin, known as surround care, that we apply for sunburn many times. And they tested this on Merlot, Sauvignon Blanc, and Chardonnay. The problem is they only got some efficacy in Merlot. And it's always concerning when you only see something working on one variety. So I asked them, and they said they didn't specifically look at it, but they think this may be a factor of that they had less coverage in the Merlot than in the Sauvignon Blanc and the Chardonnay. It could be a factor of the canopy structure or the bunch structure. That's what they said. What I don't know is if they removed the barrier sprays. So we know now that you need to remove the barrier sprays. If you're going to make wine from these grapes, or you do analysis of these grapes and you still have the barrier spray on top of it, these volatile phenols absorb onto the barrier spray if they don't go through into the berry. And if you don't remove it, it just gets desorbed to the juice or desorbed into your wine. and that would be problematic. So that could be part of the reason, because Sauvignon Blanc and Chardonnay, obviously, you make with much less skin contact. Then there was a study in British Columbia where they looked at Parka. Now, Parka is a phospholipid cuticle that they use in cranberries to prevent cracking. And they did this on Pinot Noir. They applied it a week before smoke exposure, and they saw something like 300% reduction in absorption of volatile phenols. The problem here is that when they repeated the study, it didn't look that good. They repeated the study, and what they found was that they saw an increase in the absorption of volatile phenols, which was very problematic. They did say that they applied it then 1 day, 7 days, and 14 days before smoke exposure. But in all these circumstances, there was a lot of moisture in the air, and they think perhaps the Parka didn't get dry. We know now that you don't want to apply anything onto your grapes if there's smoke in the air, because it seems anything that don't dry, anything like even fungicides that have a lot of oils in them, it's like it increases the surface area of the berry and you get more absorption into the berry, or we don't know if it impacts the cuticle in some way and you get just a easier access into the berry, but it's not a good idea to apply anything at those circumstances. So we did this study in 2021. Many people come to me asking for, telling me that they think they have something that may be able to help the grape industry. And I decided, okay, to screen all these different barrier sprays instead of spending weeks of field studies and millions of dollars. What we're going to do is we're going to do some intentional smoking. And we took individual bunches on a vine and we actually submerged it into the different barrier sprays for 30 seconds, so to get 100% coverage. We didn't apply any stickers because we didn't want to apply any oils, and to see how this is going to work. Then we did average smoke exposure. I wanted to expose it to the kind of smoke that you may see. Many times in the research studies, the smoke is really, really bad, and it's in circumstances that I don't think anything can protect the grapes. So we did that. We waited 3 days. I'm sure all these barrier sprays were dry. It was 3 days of at least 95 degrees Fahrenheit. And we wait 1 week after smoke exposure. And then we took the fruit, we rinsed off all the barrier sprays, and then had a look at it. Now, you can see, let me describe what you're looking at. So at the left, that's the free volatile phenols. And all the different volatile phenols I measure, you can see it's a little bit more, it's like around 10 compounds added together. So the buffer NS, the bar right on the most left, that's the grapevines that weren't exposed to any kind of smoke. Right next to it is control S, that's the grapevines that were exposed to smoke but had no barrier spray on top of it. Then you look at this, so the purple bar is what you're aiming for, right? And you see there's a few that's like very even to that or even lower, and it looks really good. However, when you look on the right, that's where you see the total volatile phenols. And then it doesn't look quite that good. So if we go to the next slide, we'll only look at the totals. So if you look here, what you'll see is that almost nothing got it back. Nothing got it back to a grapevine that wasn't exposed, but some were actually better than the control that had no barrier spray, and some actually made it worse. And you can see here, Parka was worse, and it was dry. This is at 1%. And the Australians have done a similar study, unbeknown to me, than I've done here. They just didn't do it on the vine. They actually also submerged bunches in different barrier sprays, but they picked the bunches and did it in like a glass container, exposing them to synthetic volatile phenols. And they also included Parka and saw the same results. It was worse with Parka. So what I saw showed some efficacy, and this supports work that Professor Thomas Collins is also doing in Washington State University. He's really focusing on kaolin and bentonite. I saw a 31% decrease in volatile phenol absorption with kaolin. And then I tried a couple of formulations from EMP Barrier. It's a polymer-based plant protection agent. both GM3E at 1% and GMB6 at like 6% showed a decrease in volatile phenols, 33 to 24% decrease. And then I also have activated charcoal. Now, it's not like I want anybody to go and spray activated charcoal on their grapes. It's black, right? You don't want to do that. It's going to attract heat. I did that because activated charcoal absorbs volatile phenols really well. We know this. So this was sort of my, okay, what's the best you can see under these circumstances? And that gave us a 30% decrease in volatile phenols. So we decided, okay, we will use those that showed the most efficacy. And then in 2022, we will do field trials with these. And that's what you're looking at here. So what we did is we actually built 4 greenhouses. And in each greenhouse, we had a different condition. So greenhouse 1, we sprayed kaolin. We made it like the manufacturers recommend. I think it's 60 grams per liter. And we sprayed it on about 50 gallons per acre if it's only on the bunch zone, and 100 gallons per acre if we sprayed it on both the bunch and the canopy. But we used a backpacker for this. So in one tent, we would do, or a greenhouse, we would do kaolin, only bunch zone for some vines, bunch zone and canopy for other vines. And we did in one greenhouse at 21 days before smoke exposure, and for another, we did it 10 days before smoke exposure. Then we did the same thing for GM3E at 1% level. In one greenhouse, we did it only in the bunch zone or in the canopy and bunch zone 21 days before smoke exposure. And for the other, we did it 10 days before smoke exposure. Why the different times? Firstly, we want to see if it will naturally break down. So, and how often you need to reapply it to get protection from smoke. Because remember, this would always be a preventative measure. This is not something you can apply when you see the smoke coming. So you need to know how often you need to reapply this so that you actually have protection. Then we did intentional smoking, 5 hours of smoke exposure for each greenhouse. And we did this overnight and then removed the sheeting so that we don't overheat the grapes. And we harvested them 21 days after smoke exposure. Then at harvest, we did no rinse and rinse. Because the other question is, do these things naturally break down or do we need to remove them? Because obviously in a place like California, if you have to remove a barrier spray with water, it's really not a very good solution. And secondly, it's actually pretty hard. I know for kaolin specifically, to remove that with water is actually quite difficult and not that easy to do. So we then also, with rinsed and no rinse, did something like, I think it was like 74 micro fermentations. And you can see there on the right are all the micro fermentations. And I don't have any data to share. We basically finished these wines less than a month ago, and we will start analysis in the new year. And as soon as I have any data, I will share it with everybody. My time is actually finished, and I'm going to skip through. I'm not going to go any further because I realized after I shared my presentation that this is the wrong presentation. So I'm going to stop here. There's 5 minutes left, and that's actually really all I wanted to say. So for me, I'm going to summarize and say that currently we know that most of the volatile phenols are in the grape skins. And we are still saying for whites if possible, and for many instances it's not possible. Hand harvesting, obviously, because the more skin damage you have, the more it will leak into the juice. Because for white wines, you can limit skin contact and potentially be okay if the smoke impact wasn't severe. Currently, we do not recommend that you need to wash or do anything in the vineyard. We're not that concerned. We don't think the amount of volatile phenols being released from ash in the vineyard is enough to allow absorption into the grape berries. It's very difficult to remove them. Wet ash gives off more than dry ash, so we don't think you need to be too concerned. I'm slightly concerned with very, very fresh ash, lots of it on grapes when you do wine processing, and perhaps blowing them off is a possibility. We're looking into that. Barrier sprays, like I said, there's a few that show some potential efficacy, but we really need to do a little bit more work. So far, it looks like GM3 and kaolin may give you some reduction. It's not a silver bullet, but it could be just enough potentially under low smoke conditions to protect you against the volatile phenols in the air. And I need to say that, and I'm going to slip very quickly so I can get to my last slides. I need to thank the USDA IRS for funding and NIFA SCRI, because without funding, obviously, I can't do any of this work or pay the people that do all this work. And thank you very much. And I see there are questions.
Yes, I will try to tackle the first question. It's a little long. So in regard to the procedure for releasing bound compounds, how confident are we that 100 degrees Celsius and a pH of 1 generates absolutely no guaiacol, cyrindrol, etc., from pre-existing phenolic compounds in the grapes, such as tannins, flavonoids, lignocellulose, or even glycosidic linkages, with those respective phenolics like naturally exist in those grapes? ? Can you elaborate on the control procedure for determining that level of confidence?
So we have done tests where obviously we looked at the stability of volatile phenols on their own under these conditions, and they're pretty stable. We have spiked with bound compounds into model solutions and into grapes and see what recovery we get. And the recovery is actually pretty low. So you do not actually get everything hydrolyzed. So I won't say it's impossible to get some contribution from those, like cellulose and things, but from my experience, those compounds are extremely stable. I do some cell wall work as well, and it's pretty difficult to get anything to release from it. And because we still have an yield that is lower than we expect when we spike and we do recovery tests, if there's a contribution, it's a low contribution, if I can put it that way.
We have probably time for one more question, Michelle.
Okay, the next question is, do you find different levels of VPs in dense canopies with lots of leaf coverage on the fruit versus canopies with exposed fruit?
I would say yes. If you a big canopy and a lot of leaves do help protect the grapes against volatile phenol exposure. The leaves are like scrubbers in the air. They absorb a lot of the volatile phenols. Now, the caveat here is we know that there's some translocation of volatile phenols from leaves to bunches, and it's possible. But at this point in time, it looks to be very minimal. The advantage of rather having a larger canopy that can protect the grapes and absorb some of the volatile phenols seems to be more beneficial than worrying about the little bit that could actually transport to the grape bunches. But we're investigating that at the moment as well.
Okay, we are done with time. Anita, is it possible for you to open up the Q&A? You have 3 more questions.
Yeah.
We don't have time to answer. If you can type in answers, I'd be greatly appreciated.
I will do that. Thank you very much.
Thank you so much, Anita.